Hey guys, welcome back to DSC. So in this video we will be doing the rules of differentiation, and this is basically a brief discussion of the theorems and examples, and we'll be dealing with all the basic rules in this video. So the first rule is the power rule. So what does the power rule says is that if we have a equation like y is of type y equals to x to the power n, then the differentiation or derivative of y, it will be n x to the power n minus 1. Either what happens is ki y is x to the power n. So this power, it first comes here and then x, and then the power gets reduced by 1. The power, it is reduced by 1. For example, if we have y equals to x square, then here y dash or dy by dx will be 2x to the power 2 minus 1, which is 2x. Similarly, y dash for x equals to 1 to the power 4 will be 1 by 4 x to the power 1 by 4 minus 1, which is 1 by 4 x to the power minus 3 by 4, which can be simply simplified as 1 by 4 x to the power 3 by 4. Similarly, for y equals to x to the y equals to x to the power 5, so this can be written as y equals to x to the power minus 5. So here y dash comes out to be minus 5 x to the power minus 5 minus 1, which is minus 5 x to the power minus 6, which can be simplified as minus 5 by x to the power 6. Hope this is clear. Now let's to the next rule. It is the extended form of this rule only. Like for example, if we are given y of such type wherein we have something as a function with x, so here the derivative will be the same way, that is power of x, then the function to the power minus 1 n minus 1 and the coefficient of x. Here a is the coefficient of x. For example, if we have y is 2x minus 5 to the power 3, here y dash will be 3, that is the power, 2x minus 1, that is the function which we have, and multiplied by the coefficient of x, that is 2. So finally this is 6 2x minus 5. Now for this question, again the same rule, y dash will be 1 by 2, power comes in front, then the equation the way it is, then multiplied by the coefficient of x. So here it comes out to be 3 by 4 and 3 by 2 x minus 3. Hope this is clear. Next we have derivative of a constant. Here it's very simple. Derivative of any constant not containing any x is 0. Be it y equals to 3, y equals to k, the derivative will be 0. Now if we have multiplicative constant rule, what does this rule says is ki if y is of the type k x to the power n, here what we can write here is k and x to the power n. So if we have any constant multiplied with x, it will be as such, and we will be differentiating x to the power n. And how to differentiate x to the power n? It's again n into x to the power n minus 1. So whenever we have any constant multiplied with x, then the constant comes the way as it is, the way it is. Isme we have y equals to 10 x to the power 4. So here dy by dx will be, as 10 is the constant, it will remain the way it is. Now 4x to the power 4 minus 1, which is 10 into 4 is 40 x to the power 3. So this is the solution. Now for this we have we can simply write it as 3 by 7 x to the power minus 2. Right? This is a kind of simplified way or a better way for solving it. So here y dash will be constant as it is, the power of x multiplied by x, the power minus 1. So it is it is minus 6 by 7 x to the power minus 3, which is minus 6 by 7 x cube. So this is the answer. Next we have the derivatives of sum or difference. Like it can be a sum, it can be a difference, it hardly makes any difference, of two or more functions if we have more than one function. For example, if y is any type with u plus v, where u is also a function of x, v is also a function of x, then how the differentiation will be solved is, we'll first differentiate u with respect to x and v with respect to x, and we'll simply add or subtract them as per the requirement of question. For example, in this question we have y equals to 3x cube plus 4x square plus 5x minus 3. So here dy by dx what we can do is we can simply do it by like first 3x cube ka differentiation, it is it is 9x square, then 4x square it's 8x, for 5x it's 5, and for minus 3 it's 0. What we can do is we can take them simply like individually and then subtract or add them, or we can just do it simply like 3x cube is 9x square plus 4x is 8x plus 5. So this is our answer. This is the derivative which I was talking about. For example, we have one more example here. So here this is a kind of product of two. So what we can do is we can simply rather than using the product rule here, what you can do is you can use the product rule here. But if you aren't comfortable with the product rule, what we can do is we can simply solve this equation. Multiplying x with 2x, it's 2x square, then it's minus x minus 2x plus 1. Solving it, we have 2x square minus 3x plus 1. Now we can find the dy by dx here, which is 4x minus 3. So this is the required solution. Is it clear? Looking onto the product rule now, if y is multiplication of two functions and these two functions are indeed function of x, so how to solve this? So there's a rule to solve this, and that is known as the product rule. This is basically y dash is first function as it is, second ka derivation, plus second function as it is, first ka derivation. Simple. Looking onto this question, we have y is x to the power 5, considering this as first function, 2x square plus 1 considering this as second function. We have y dash as first function as it is. Now differentiation of 2x square plus 1. So this is the power rule, the extended form, or basically it is the power rule multiplied with the constant. So it is 2 as it is, 2x to the power 1 plus derivative of constant is 0, plus second function as it is, that is 2x square plus 1, first ka differentiation, which is the power rule, 5x to the power 4. So it comes out to be x to the power 5, 4x plus 10x to the power 6 plus 5x 4. Solving this, we have 4x to the power 6 plus 10x to the power 6 plus 5x to the power 4, which is actually 14x to the power 6 plus 5x to the power 4. So this is the solution. So we have this question again. So it is basically, again we will be using the product rule. U is x minus 1 and v is 2x minus 1. So here dy by dx, it will be first function as it is, second ka differentiation, which is 2, plus second function as it is, first ka differentiation 1. So it is 2x minus 1 plus rather it's 2x minus 2 plus 2x minus 1. So it is 4x minus 3. So this was the answer which we got previously. Next we have the extension of the product rule. What if we are given a function wherein we have three functions multiplied? What we can do is either u is also function of x, v is also function, w is. So here no one is constant, like we can just like use it the way we normally use it, keeping it as it is. What we have to do is all the three are function of x. So what we do is uv ko we assume one function, fine, and w ko we assume the second function. So let us apply the product rule. First function as it is, uv as it is, second ka derivative, that is d by dx of w, plus second function as it is, that is w. Now we have the derivative of first function here. Again we can do it इसी को similarly what we can do is इसका differentiation करना है, which is u, wait a minute, which is u v dash plus v u dash. वही किया, u v dash plus v u dash. Fine. Let us consider this example. This is x plus 3, u हो जाएगा x plus 3, this is u, this is v, this is w. Now here y dash will be, we are taking these two as a single function. Fine. So let me make it a bit clear. These two are a single function, right? So first function as it is, x plus 3 as it is, 2x plus 3 as it is. Second ka differentiation, x square ka differentiation is 2x, plus second function as it is, x square plus 1. First ka differentiation, है, वी कैन हैव अ बिगर ब्रैकेट. अब इसमें इसका डिफ्रेंसिएशन करना है. इसका डिफ्रेंसिएशन कैसे होगा? फर्स्ट फंक्शन एज इट इज, फिर से सेकेंड का डेरिवेटिव विच इज 2 प्लस सेकेंड फंक्शन एज इट इज 2x प्लस 3, फर्स्ट का डिफ्रेंसिएशन 1. So opening this, we get 2x square plus 3x plus 6x plus 9. We have just simply opened this, multiplied with 2x plus x square plus 1, and now we have this as 2x plus 6 plus 2x plus 3. Again opening it, like simplifying it, we have 4x cube now plus 6x square, rather we can add it, that is 9x, so 9 2s are 18x square plus again 9 2s are 18x, plus now we can add these two, which is 2x plus 2x is 4x plus 6 plus 3 is 9, so we can have this instead of whole of this, so we can have 4x plus 9. Multiplying this, we have 4x cube plus 9x square plus 4x plus 9. Now we can take these two terms, 4 plus 4, 8x cube. Now we have the x square terms, 9 plus 18 is 27 x square, 18 plus 4 is 22 x plus 9. So this is our solution, the required solution. So now we have the quotient rule. What the quotient rule says is, if y is any function of type u by v where the two are divided, so here again we have a rule to solve that, but the condition is that v or the denominator should not be 0, because if this is 0 then y here becomes infinity, right, which cannot be possible. So dy by dx is second function as it is, first का differentiation minus first function as it is, second का differentiation upon the denominator का square. So this is first, this is second. So it is basically second function as it is, u dash minus first function as it is, v dash upon v का square. Taking this example, we have 8x by x cube plus 1. So y dash will be second function as it is, first का differentiation which is 8, and now we have minus first function as it is, second का differentiation is 3x square upon x cube plus 1 का whole square. Simplifying it, we have 8x cube plus 8 minus 24x cube upon x cube plus 1 का whole square, which is 8 minus 16x cube upon x cube plus 1 का whole square. So now here we have another question, which is y equals to under root of 1 plus x upon 1 minus x. So we can simplify it as root of 1 plus x upon root of 1 minus x, which can be more of simplified into 1 plus x to the power 1 by 2 upon 1 minus x to the power 1 by 2, right? So what we can do here is, we will be applying the quotient rule, taking this as first function, this as second function. So y dash will be first function, like second function as it is, this is as it is, into first का differentiation. So we are applying the power rule here, 1 plus x to the power minus 1 by 2. I hope that was clear. And now we have coefficient of x as well, minus first function as it is, second का differentiation which is 1 by 2, 1 minus x to the power minus 1 by 2. Again the coefficient of x here is minus 1 upon whole upon 1 minus x to the power 1 by 2, right? To the power 2, because it is square. Simplifying it, what we get is, we can write it as 1 by 2 taken outside, and this as 1 minus x to the power 1 by 2 upon 1 plus x to the power 1 by 2. Why? This is similar as x to the power minus 1 is 1 by x. If it is minus, the variable goes into the denominator, minus and minus. So when they two multiply, we have plus. Again 1 plus x to the power 1 by 2 upon 1 minus x to the power 1 by 2 whole upon 1 minus x. Why? because here the power have cancelled themselves. This comes out to be, taking 1 by 2 common outside, we are taking LCM now. So it's 1 minus x to the power 1 by 2 and 1 plus x to the power 1 by 2. Now here it will be 1 minus x plus 1 plus x. Normally how we use, how we used to solve LCM? So this is whole upon 1 minus x. Again taking 1 by 2 outside, now we have this denominator and this denominator, so it can be written as 1 minus x plus 1 plus x upon 1 minus x to the power 1 by 2, 1 plus x to the power 1 by 2 multiplied by 1 minus x. So we have three things in multiplication in the denominator. So it is 1 by 2. Here we have x to x cancel because they are like negative. So it's 2 upon, the base is same here, so the power gets added. Like if we have a to the power b into a to the power c, it will be a to the power b plus c. Similarly 1 minus x to the power 1 plus 1 by 2, which is 3 by 2 into 1 plus x to the power 1 by 2. Here 2 gets cancelled, so the answer is 1 by 1 minus x to the power 3 by 2, 1 plus x to the power 1 by 2. Now this question can also be solved using the product rule. How? Like we can take the power of 1 minus x as, like we can just simply write this equation as 1 plus x to the power 1 by 2 multiplied by 1 minus x to the power minus 1 by 2. This way now it is a product of two numbers. This is first, this is second, and we can use the product rule here. Fine. So this is the chain rule. Chain rule says is that if y is a function of x and u is also a function of x, then how to find dy by dx. So here if we like kind of simplify it, we'll get dy by dx. So the way of saying is y dash in terms of u, so it is dy by du multiplied by derivation of u in terms of x, which at last gives us the derivation of dy by dx. Looking on to the extended form, if y is a function of w, w is a function of z, and z is again a function of x. So here at last what we have to find is dy by dx. So dy by dw, this one with respect to w, with respect to z, with respect to x, and at last we'll be getting dy by dx. This can be, so we'll have a better understanding by considering a question. Here y is u square plus 4u and u is x square plus 4. So for dy by dx, what we need is dy by du multiplied by du by dx. So here y is 4 square plus u square plus 4u. So dy by du will be 2u plus 4 and u is x square plus 4. So du by dx, rather it's dy by du, it will be 2x plus 0. So getting 2u plus 4 multiplied by 2x. Putting the values of u, that is x square plus 4 plus 4 whole multiplied by 2x. So it is 2x square plus 8 plus 4 whole multiplied by 2x. So it is 2x square plus 12 whole multiplied by 2x, which is that is 4x cube plus 24x. This is the required solution. So we can solve this question by a different method, the same question. So here y is u square plus 4u and u is x square plus 4. So here itself we put on the values of u in terms of x. So y will be x square plus 4 whole square plus 4 x square plus 4. Simplifying it, we get y as, this is a plus b whole square, which is a square plus b square plus 2ab, right? So y is x square ka square, that is x to the power 4, plus 4 ka square is 16, plus 2 into x square into 4, which is 8x square, plus 4x square plus 16. Solving it, we have x to the power 4 plus 16 and 4 is 16 and 16 is rather 32, plus 8 and 4 is 12x square. This is y. We have to calculate dy by dx, that is power rule 4x cube plus 32 का 0, and now it's 24x, 24x, not square. This is our solution. So that was it for the video. In the next video, we'll be considering the important questions of all the rules of differentiation, and then we'll be having the derivative of implicit functions. Till then, practice hard, and please like, share and comment on the video, and please let me know if there's any mistake while solving the question so that I can rectify or pin it in the comment section. And do subscribe to the channel so that you keep us motivated, and we strive to bring you good content every day. So thank you for watching. Till then, stay tuned.